We're starting a new day, so let's share our screen and let's quickly take the next task. So this one, implement queue using stacks. So we have to implement the first in, first out queue using only 2 stacks. Right. So I think the logic is pretty similar to what we had on the previous task. So how stack works. So let's imagine that we have A and B and C. So if we put it on the stack, so first we put A, then B, and then C. So in this case, we should like put into another stack all these values, but we can have like once again the same one. So we just take them out and put once again into the stack on each push. So let's implement this. So let's have like private stack integer stack. And on push, what we do, we so we should do stack push, and while let's do like this. So we just iterate because for example, if we push on the stack, so for example we have A, B, and C, right? So now this one would be on the top of the stack. So we take C and we put it back. So yeah, so we have the same. So we need what we need another stack. So we need here to create another stack and then just to change it. Yeah, so what we do, we create another stack. Here while our stack is empty false, we add let's say we push stack pop, and then we just keep the references, and from here we just do a stack pop return, and here we do return stack pick and return stack is empty. Let's run. Let's submit. Okay, so we have wrong answer. So let's check. So we have our queues and we push 1, 2, 3, 4. Then we pop. We should pop. Okay, we should pop this one. Then we push 5. Yeah. So problem, I believe, with this one. Push, 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 push. So we push all these values and we pop and push 5. So let's imagine this. So we have empty stack. So we push 1, then we push 2, then we create another stack. We take from the stack 2, so we push 2 and 1. Then we have 3, so we have 2, 1, and then 3. Then we take 3 and 1, then 2. And after this we push 4. So we have 3, 1, 2, and 4. So I believe we should not do it here. So here we should just push, but when we pop, we should do the following. We should empty our stack and then put once again into the stack. So what we do, so for example, here we push all element 1, 2, 3, 4, and now I want to take this one. So on pop, I'm popping this 4 and push it, then 3, then 2. But then I need to reverse somehow. So so maybe I need 2 stacks here. Okay. So let's have here like another stack. So we integer s. So while stack is empty, while it's not empty, we just do as push stack pop, and here it would be our result, just pop from s, and then we should do while s is empty, we should put once again into the stack as pop, and here we return result. Let's run. Okay, so what we have here, so we push 1 and 2, and and then on peak we have this problem. Then on peak we have this problem. I think maybe let's, like, we have a top value that would be in null, and when we pop, we update our top with with SP every time. So we push. No, it would be not enough. Okay. Yeah. So on peak we still need actually to do the same logic, but here we should do peak and return result. Yeah, looks ugly. Looks ugly, but let's check solutions. Approach 1, 2 stacks. On push. Yeah, so we can do it on push or on pop actually. Yeah. Two stacks push. Yeah. We can do it on pop. Yeah, looks like quite strange task, but we already solved it. So let's go to the next one, min stack. Design a stack that supports push, pop, top, and retrieving the minimum elements in constant time. Implement stack class. Okay, so we have to implement all these methods in constant time. And method pop top and get min operation will always be made on a non-empty stack. Okay, so we should not take validation into our account. So let's try to think. So if it's a stack, it means what does it mean? And then all should be run in constant time, right? For each function, okay. If it would be a linked list, then we have so we can be linked list with get min. Okay, so I think it can be linked list maybe with priority queue, but priority queue, like it's very hard to synchronize between these two structure. Especially like when we pop element and it's a minimal element, and also when we push it will be not constant. So and also if it would be an array, let's see, so value can be pretty like all possible integer value, and also for 10,000 calls. Get min stack push. Let's think. Design stacks that support push, pop, top, and return the minimum element is constant. Get min. Yeah, I think priority queue is the best one, because if it would be pop and we are popping the minimum, then we just pop also from priority queue. But when we push, we actually need, it would be lock time, so it would be not constant. It would be not constant. What do we have? Hash map with previous minimum. So for example, we put our element. Yeah, so it would be stack with pairs. And we have min. Yeah, so it would be stack with nodes maybe. Let's think like this. So we have a class node with value and also node next. And also let's say that we have some constructor for node. Let's say that we have yeah. And in this constructor we have this value. Is it equal to value? And also this node is it equal to node? And yeah, so in this case we also have node min. That would be null on creation. And also we have a stack of nodes. Empty stack at the beginning. And when we push our element, no, it will not work. Yeah, it will not work because we need. Yeah, it will not work because we need also to store greater elements. Okay, so let's go with hint. Consider each node in the stack having a minimum value. Okay, so what if we have here a minimum value, right? And then we have a linked list of node and let's say, yeah, it linked list, so we have int value and also int minimum value. And also we have node next, maybe not previous, because we need previous, right? Yeah, I think we need previous. I'm not sure about node next, but yeah, so let's have node previous. And also we have int min. So here we have previous equal to previous, and then this min equal to min. And here we have node head. It would be empty. So when we push, we check if head equal to null. We do like head equal to new node value. Then value would be the minimum, and the previous would be null. Else head, we create new node with value, then mass mean between head, it will be previous value, previous mean, and head, it will be previous. So here we have like new head, and then head is equal to new head. Okay, and then with pop we just what we do, it would be our result. We just take head, we just do head, and we actually equal head previous. So we just pop this value, but we don't need to return. Here we just return head value, and get minimum, it will be return head minimum from. Okay, line 3. Line 3, what did we miss? So here we have all correct. Then here also we have all correct. Don't think we need this one. Okay. Oh, it's here. Oh, value. Okay, so we're done with the first test. Let's submit. Okay, and we're done with the second one. So this hint, was really helpful, because we can store this minimum all the time. So I believe that here we also so we have the similar implementation with previous, and also with 3 parameters with records as well. Yeah, so the same implementation. Yeah, it's also the same here. Same here. All right, so we're done with min stack. And yeah, I think that's pretty much for today. So let's stop and see you tomorrow.